I'm Sandor Nagyszalanczy, contributing editor to Woodworker's Journal magazine. And if you've accepted personal computers as being tools that are just as important in a modern woodshop as chisels and hand planes, then this new little machine is probably going to blow your socks off. It's called the Handibot, and it's basically a small, portable CNC router that uses a computer program to drive these precise stepper motors, which move this compact router in 3 axes, up and down, front to back, and side to side, allowing it to perform a fully automated routing operation. Although the Handibot is just as accurate and versatile as a large stationary CNC machine, it has an important distinction, and that is that you bring the machine to the workpiece instead of the other way around. You can set the Handibot on top of a small board, a large beam, or even the side of a barn. Any surface that you can set this machine on, you can route. Like other CNC routers, Handibot does all kinds of automated routing tasks, including shaping and cutting out small parts, boring holes for mounting hardware, making signs, and even carving complex patterns with ease and repeatability. Automated routing starts with a part program created with software such as VCarve Pro. For this example, I'll make a wood sign with carved letters. After typing and orienting the text, I must create a toolpath, a set of instructions that tells Handibot how to move the router. After specifying a few things, including cutting depth and the kind of bit to use, the program generates the necessary computer codes. We can then see a preview of the sign as the Handibot will route it, and even rotate the preview image in 3 dimensions. Before running our program, though, we need to set up the Handibot. First, we'll install the necessary bit in the compact router's collet. Next, we'll connect Handibot to the computer via a USB cable. We'll also hook up a shop vac hose to the unit's dust port. It's now necessary to zero the Handibot's up and down, or Z axis, so that the router bit will cut at the correct depth. With a piece of paper under the bit, I use software controls to lower the router until the bit just touches the paper. Then in the software, I select the Z axis and click to zero it. To zero the machine's X and Y axis, Handibot uses a built-in program that sets the router's maximum travel, both left and right, and front to back, then returns it to its home position. Now with the workpiece secured and clamped to the bench top, I set the Handibot on top and position it carefully. For this light routing operation, just the weight of the unit alone is enough to keep it in place. I now load the parts program I created earlier with VCarve Pro into the Handibot's control software. Then I press the Start button and stand back and watch the automated routing action create my wooden sign. Pretty nice, huh? In order to hold smaller parts securely during routing, I made a simple baseboard fixture, into which is routed a shallow pocket sized to fit a thin workpiece, out of which I'll create some ukulele-shaped name tags. A couple of pieces of masking tape keep the part in place during routing. 4 corner tabs that I glued and nailed to the baseboard serve to precisely position the Handibot over the workpiece. I'll route each name tag in 2 separate operations. First, engraving a name on each mahogany blank using a 60-degree V-bit. I remove the blank after this operation and then route all the other blanks in turn, engraving a different name on each one using the same V-bit. Now in the V-Carve program, I create a toolpath for an 1/8" straight bit that will shape the outside of each name tag and cut it from the blank. Several small tabs are left in the cutting path to keep the tag in place during routing. The tabs are thin enough to allow the name tag to be separated from the blank with hardly any effort. Although the Handibot has a basic capacity of only about 8 by 6 inches, doesn't mean you can't use it for much larger routing jobs. For example, if we wanted to carve a repeating pattern down the length of this beam, we'd simply set up the Handibot for the first operation here, then we'd carefully mark and reference it so that we could reposition it, and then run a program to carve the second section of the beam, and then simply repeat the process over again as many times as necessary to complete the carving.